Good evening, all. So this is week 6 fabrication technique for MEMS based sensor clinical perspective. This is a problem-solving session. I'm Arpita Biswas, a PhD scholar um, in electrical engineering department from IIT Jodhpur. Um, this is more about me. So we are going to start the session after 2-3 minutes. Let's join others also. Then we will start the session. So let's start the session. This is the question number one. Piezoelectric and piezoresistive are two types of sensor that are commonly fabricated using the technique in microfabrication. What is the difference between these two type of sensor? First option, there is no difference. Both are different names of the same phenomenon. The second option is piezoelectric sensor accumulate charge in response to the mechanical force, while piezoresistive sensor cause a change in resistance in response to the mechanical force. And third option is piezoelectric sensor are easier to interference with data acquisition system than piezoresistive. And the fourth option is none of the above. So go through the question carefully and try to give the right answer. So what is the right answer? Piezoelectric and piezoresistive are two types of sensor that are commonly fabricated using the techniques in microfabrication. What is the difference between these two types of sensor? First is there is no difference, both are different names of the same phenomenon. The second is piezoelectric sensor accumulates charge in response to mechanical force, while piezoresistive sensor cause a change in resistance in response to the mechanical force. Piezoelectric sensors are easier to interference with the data acquisition system than piezoresistive. And the fourth option is none of the above. So please go through the question carefully and try to give the right answer. So the right option is option B, right? Piezoelectric sensor accumulate charge in response to mechanical force, while the piezoresistive sensor cause a change in resistance in response to the mechanical force. The right option is option B. So next, move towards the question number 2. Gold and platinum interdigited electrode have a thin layer of chromium or titanium deposited beneath the electrode. Why this is done? The first option is to avoid the AU or PT from etching with the oxide below. And the second option is the metal like AU PT have poor adhesion to oxide or a thin layer of chromium titanium improve the adhesion. And the third option is to reduce the cost of usage of metals like AuPT, a thin layer of chromium and titanium is deposited. And the last option is none of the above. So please go through the question carefully and try to give the right answer. Gold and platinum interdigited electrode have a thin layer of chromium or titanium deposited beneath the electrode. Why this is done? First option is to avoid gold or PT from reacting with the oxide below. Second option is metal like AU or PT have poor adhesion to oxide. A thin layer of chromium or titanium improves the adhesion. And the third option is to reduce the cost uses of metals like AU or PT. A thin layer of chromium and titanium is deposited. And the last option is none of the above. What is the right answer? The right answer is option E. Metal like EU and PT have poor adhesion to oxide. A thin layer of chromium and titanium improve the adhesion. Okay. So next move toward the question number 3. Base resistance value of chrome and gold ID structure with a spacing of 20 microns and 25 microns is X ohm and Y ohm, respectively. What is the relationship between the X and Y? First option is X less than Y. The second option is X greater than Y. The third option is X equal to Y equal to high rate. And the last option is both are zero. So please find out the right answer. So the right answer is option C. X equal to Y equal to high rate. Okay. So next move toward the question number 4. Properties measured using the ETM sensor for breast cancer tissue phenotyping are: first option is capacitance, elasticity, specific heat. The second option is the capacitance, viscosity, thermal conductivity. And the third option is resistivity or resistance, elasticity, and the thermal conductivity. Resistivity or resistance. The fourth option is resistivity or resistance, viscosity, and or a specific heat. So go through the question carefully. Go through the question carefully and try to give the right answer. So what is the right answer? The right option is option C. Okay. Resistivity, resistance, elasticity, thermal conductivity. So next move toward the question number 5. We have seen the SO8 material being used in the device fabrication in the ATM device as well as the piezo-resistive micro cantilever device. Which of the following statements are true in this regard? The first option is a civet player were used in the ATM device to ensure the electrical contact with the IDS. And the second option is the AC weight was used in the piezo-resistive device to transfer the force onto the piezo-resistive material. So first option is 1 1D and the second option is 2 1D. The third option is both 1 and 2, and the fourth option is neither were or not 2. So go through the question carefully and try to give the right answer. So, what is the right answer? The right answer is option C, both A and B. Okay. So next question is SO8 is a negative photoresist. Areas of wafer covered with the SO8 when exposed to the UV light will first is harden, the second one is soften, the third one is remain the same, and the fourth one is cannot determine. So please go through the question carefully and try to solve the question. What is the right answer? So what is the right answer? So the right answer is option A, harden. Okay. As the negative photoresist is a negative photoresist, so the exposed portion of the negative photoresist become harder. Okay, and which one is not exposed, it becomes softened, and when we are going for the developing process, then it's etch out. Okay, so the right option is option A, harden. So next move toward the question number 7. Silicon nitride is grown over the cantilever to induce additional stress in the cantilever. True or false? So the right option is false. Option B. Okay. Next move toward the question number 8. In the IDE fabrication process or any other fabrication process, acetone dip is done to remove The first option is gold, the second option is nichrome, third option is chromium, and the fourth option is photoresist. So go through the question carefully and try to solve the answer. In the ID fabrication process or any other fabrication process, acetone dip is done to remove. First option is gold, second option is nichrome, third option is chromium, and the fourth option is photoresist. So which one is the right answer? So the right answer is photoresist. Okay. Because only for gold we have used the gold agent. For nichrome also, chromium also there are some other agent are used. But in the case of photoresist, we dip the wafer into the acetone. Okay. So the right option is the photoresist. So next move towards the question number 9. Silicon on insulator is a special type of silicon wafer. Evaluate whether the statement below about the SOI wafer is true or false. And the statement is SOI have a thin layer of silicon over a thick layer of silicon separated by a thin layer of insulator, such as oxide. So is it is true or false? The question is silicon on insulator is a special type of silicon wafer. Evaluate whether the statement below about the SOI wafer is true or false. SOI have a thin layer of silicon over a thick layer of silicon separated by a thin layer of insulator such as oxide. So it is true or false. Take your time. There is no hurry, but at least try. So which one is the right answer? Go to the question. Which one is the right answer? Silicon on insulator is a special type of silicon wafer. Evaluate whether the statement below about SOI wafer is true or false. So SOI have a thin layer of silicon over a thick layer of silicon separated by a thin layer of insulator such as oxide. So is it true or false? So which one is the right answer? The right option is option E. So it is true. Okay. So SOI have a thin layer of silicon over a thick layer of silicon which is separated by a thin film. So next move toward the question number 10. Why do biosensor have microheaters beneath the interdigited electrode? First option is at elevated temperature, sensitivity increases. Second option is to maintain the normal human body temperature on the chip. And the third option is matrixel, which is often used, is stable only elevated temperature, 320 K. And the fourth option is all of this. So please go through the question carefully and try to solve the answer. So why do biosensor have the microheater beneath the interdigited electrode? So the right option is option D. Okay, to maintain normal human body temperature on the chip. So why do the biosensor have microheaters beneath the interdigited electrode? To maintain the normal human body temperature on the chip. So next move toward the question number 11. What is the purpose of using buffer hydrofluoric acid in the process described? The first option is to deposit the chrome gold on the wafer. The second option is to etch the nichrome for the microheater. Third option is to etch the silicon dioxide from the wafer. And the fourth option is to strip off the photoresist layer. So please go through the question carefully and try to give the right answer. So what is the right answer? So what is the right answer? What is the purpose of using the buffered hydrochloric acid in this process described?
Option C.
Yes. Okay. Option C is the correct answer. Good. To etch the silicon dioxide from the wafer, we dip this wafer into the BHF solution. Okay, good. So the next question is, what happened to the photoresist during the UV expose when using a bright field mask and the positive photoresist? The first option is the exposed areas become stronger. The second option is the exposed area become weaker. And third option is the unexposed areas are removed. And the fourth option is option D. The fourth option is the entire photoresist layer is removed. So which one is the right answer?
Option B.
Yes, option B is the right answer. The exposed area become weaker. Good. So next we are moved toward the question number 13. After the final acetone dip in the process, what remains on the wafer? The first option is only the photoresist, and the second option is only the chrome gold layer. And the third option is a microheater with an insulator and interdigited electrode. And the fourth option is a silicon wafer with a um, protective layer of photoresist. So which one is the right answer? After the final acetone dip in the process, what remain on the wafer? Only the photoresist. The second option is only the chrome gold layer. The third option is a microheater with an insulator and interdigited electrode. And the fourth option is a silicon wafer with a protective layer of photoresist. So which one is the right answer? Take your time. There is no hurry, but at least try. After the final acetone dip in the process, what remains on the wafer? Only the photoresist. only the chrome gold layer, or a micro heater with an insulator and interdigited electrode. And the fourth option is a silicon wafer with a protective layer of photoresist. So the right option is option C, a micro heater with an insulator and interdigited electrode. Okay. So next move toward the question number 14. What is the purpose of SU8 pillar mentioned in the fabrication process? The first option is to act as an insulating layer. The second option is to make the gold pad conductive. Third option is to make form the interdigited electrode. And the fourth option is to deposit the chrome gold on the wafer. So please go through the question carefully and try to give the right answer. So what is the right answer? So the right answer is option B, to make the gold pad conductive. Okay. So next question is question number 15. What is the main purpose of the interdigited electrode in the described sensor? So first option is to measure the electrical signal related to the tissue stiffness. The second option is to provide a heating element for the microheater. And third option is to protect the underlying silicon dioxide layer. And the fourth option is to enhance the structural integrity of the wafer. So go through the question carefully and try to solve the answer. So what is the main purpose of the interdigited electrode in the described sensor? The first option is to measure the electrical signal related to the tissue stiffness. The second option is to provide a heating element for the microheater. The third option is to protect the underlying silicon dioxide layer. And the fourth option is to enhance the structural integrity of the wafer. So which one is the right answer? So the right answer is option A, to measure the electrical signal related to the tissue stiffness. Okay. So next question is question number 16. What is the purpose of the microheater in the described biochip? So first option is to measure the electrical properties of the tissue. The second option is to measure the thermal conductivity of the tissue. And the third option is to create the interdigited electrode. And the fourth option is to deposit the piezo-resistive material. So which one is the right answer? So the right answer is option B, to measure the thermal conductivity of the tissue. Okay. So next move toward the question number 17. What type of material is P.PSS used in the fabrication process? First option is conducting polymer. The second option is insulating material. The third option is the metallic conductor. And the fourth option is the photoresist. So which one is the right answer? So P.PSS is a which type of material? Conducting polymer, insulating, or metallic conductor, or photoresist? So P.PSS is a conducting polymer. Okay. So the right option is option A, the conducting polymer. So next move toward the question number 18. Why is an insulating material used between the microheater and interdigited electrode? Go to the question carefully. Why is an insulating material used between the microheater and the interdigited electrode? First option is to improve the thermal conductivity of the chip. The second option is to prevent the short circuiting between the metal layers. The third option is to enhance the adhesion of the electrodes. And the fourth option is to reduce the overall thickness of the device. So try to find out the right answer. So which one is the right answer? The right option is option B, to prevent the short circuiting between the metal layers. Okay. So next move towards the question number 19. What combinations of metal is used to improve the adhesion when depositing the gold on the chip? First option is nickel and gold. The second option is silver and platinum. The third option is copper and chrome. And the fourth option is chrome and gold. So try to find out the right answer. What combination of metal is used to improve the adhesion when depositing the gold on the chip? If you go through the lecture, you can see that there they have deposited like 215 nanometer. If we deposited the gold, but gold has the poor adhesion. Okay, so some thin layer of some metal is deposited to increase the adhesion. It is around the 25 nanometer. Okay. So what is the now the question is what combination of this metal is used to improve the adhesion when depositing the gold on the chip. So the first option is nickel and gold. The second option is silver and platinum. Third option is copper and chrome. Fourth option is chrome and gold. So which one is the right answer? Right option is option D, chrome and gold. Okay. So next move towards the question number 20. What is the purpose of performing a heart wave after developing the photoregister? So first option is to split off the photoregister completely. The second option is to deposit a new layer of insulating material. And the option C is to strengthen the photoregister and prepare it for aging. And the last option is to initiate the aging of the photo. So please go to the question carefully and find out the right answer. The right answer is option C, to straighten the photoresist and prepare it for aging. Okay. So next move toward the question number 21. How can acid peeler be made conductive? So first option is by doping them with the silicon. The second option is by coating them with the metals such as chrome gold. The third option is by applying a high voltage across them. And the fourth option is by exposing them to UV light. So, what is the right answer? Toward the question number 23. What is the key limitation of E-beam or thermal evaporation mentioned in the lecture? So first option is it cannot be used for patterning metals. Second option is it require a vacuum environment. The third option is it has poor state coverage, especially on the SU8 feeder. And the fourth option is it is too expensive for large scale production. So go through the question carefully and try to solve the answer. So what is the key or what is the key limitation of E-beam or thermal evaporation mentioned in the lecture? It cannot be used for patterning metals. It requires a vacuum environment. It has poor state coverage, especially one SU8 filler. Or option D, it is too expensive for large scale production. The right option is option C. It has poor state coverage, especially one SU8 filler. Okay. So next move toward the question number 24. How is lift-off technique different from the standard photolithography? First option is lift-off uses a thicker photoresist to allow the metal removal after deposition. The second option is lift-off requires a negative photoresist instead of positive. And the third option is lift-off does not require any baking step. The fourth option is lift-off is only used for non-metallic materials. How is the lift-off technique different from standard photolithography? First, lift-off uses a thicker photoresist to allow the metal removal after deposition. Second option is lift-off techniques with negative photoresist instead of positive. Third option is lift-off does not require any baking steps. And option D is lift-off is only used for non-metallic materials. To find out the right answer. The right option is fast. Lift up uses a thicker photoresist to allow metal removal after the deposition. So next move toward the question number 25. What is the final goal when developing in described space device for clinical research? The first option is to make the device as large as possible. Second is to ensure that the device is portable and cost effective while maintaining the performance. And third option is to replace all existing clinical devices. And the fourth option is to focus only the breast cancer detection. So which one is the right answer? Try to find out the right answer. The right answer is option B, to ensure the device is portable and cost effective while maintaining the performance. So next move toward the question number 26. What is the gold standard diagnostic tool for breast cancer mentioned in the lecture? First option is ultrasound. The second option is MRI and mammography. Third option is CT scan, and option D is X-ray. So please go through the question carefully and try to solve the answer. The right answer is Option B, MRI and mammography. Okay. So next move toward the question number 27. What is the purpose of piezoresistive microcantilever in tissue analysis? The first option is to measure the electrical properties of tissue. The second option is to measure the surface roughness and stiffness of tissue. The third option is to act as a thermal insulator. And the fourth option is to depict the silicon nitride on the tissue. So go through the question carefully and please try to solve the right answer. Try to solve the question. I'm coming back in 1 minute. The right answer is to measure the surface roughness and the stiffness of the tissue. Okay. So next, move to the question number 28. Which material is used to make the tip of the cantilever in the described sensor? First option is SU8. The second option is silicon nitride. The third option is boron. And the last option is silicon dioxide. So try to find out the right answer. The right answer is option A, SU8. Okay. So next move toward the question number 29. How does the piezoresistive material in the cantilever detect the changes in tissue stiffness? First option is by changing the color when bent. Second option is by changing the resistance based on the strain induced by bending. The third option is by emitting the light when pressed. And the fourth option is by heating up when in contact with the tissue. Please go through the question carefully and try to solve the question. How does the piezoresistive material in the cantilever detect changes in tissue stiffness? By changing the color when bent, by changing the resistance based on the strain induced by bending. Third option is by emitting light when pressed. And the fourth option is by heating up when in contact with the tissue. So, what is the right answer? The right answer is option B, by changing the resistance based on the strain induced by bending. Okay. So next move toward the question number 30. What is the role of SOI, silicon on insulator wafer, in the fabrication of the cantilever? So first option is to provide the thermal insulation. Second option is to act as the base material for the cantilever structure. Third option is to measure the electrical conductivity. And the fourth option is to provide a protective coating for the cantilever. So which one is the right answer? What is the role of SOI wafer in the fabrication of the cantilever? So first option is to provide the thermal insulation. The second option is to act as the base material for the cantilever structure. The third option is to measure the electrical conductivity. And the fourth option is to provide a protective coating for the cantilever. So which one is the right answer? The right answer is option B, to act as a base material for the cantilever structure. Okay. So next move toward the question number 31. What method is used to release the micro cantilever from the silicon substrate? First option is the chemical etching. The second option is the thermal evaporation. And the third option is the ion implantation. And the fourth option is the deep reactive ion etching, DRI. So find out the right answer. Go through the question carefully. What method is used to release the micro cantilever from the silicon substrate? Chemical etching, thermal evaporation, ion implantation, or deep reactive ion etching? Try to solve the question. The right answer is option D, the deep reactive ion etching, DRI. Okay. So this is the last question, question number 32. What is the relationship between the tissue stiffness and cancer diagnosis as discussed in the lecture? The first option is cancerous tissue typically have different stiffness, leading to a change in resistance that can be detected. And the second option is stiffness has no correlation with cancer diagnostic. Third option is only uh, benign tissue show the changes in stiffness. And the fourth option is the stiffness is used only for determining the tissue elasticity, not for cancerous diagnosis. So go through the question carefully and try to find out the right answer. Which one is the right answer? What is the relationship between tissue stiffness and cancer diagnosis as discussed in the lecture? Cancerous tissue typically have different stiffness, leading to change in resistance that can be detected. The stiffness has no correlation with cancer diagnosis. Only the benign tissue show changes in stiffness, or stiffness is used only for detecting the tissue elasticity, not for cancer diagnosis. So, which one is the right answer? So the right answer is option A. The cancerous tissue typically have the different stiffness, leading to a change in resistance that can be detected. Okay. So today after this, next class is next Tuesday, 7 to 9 p.m. Okay. Thank you.